Hi friends, here is another type of problem of sum of n terms. In this problem we have to find out the sum of this arithmetic series where the first term is 7 and the last term is 84, right? And we can easily calculate the common difference also. So let's first write whatever we have got, right? We have got the first term as 7 and the last term as 84, and the common difference we can calculate, that is 10 and a half minus 7. That is first term, second term minus first term will give you the common difference, right? So it is 21 upon 2, because 10 to the 20, 20 plus 1, 21 upon 2 minus 7, right? So now if there is nothing, there is 1, so I can take 2 LCM, so 21 minus 7, right? So 7 and this 2 will multiply, 1 to the 2, that's why it's 14. Now 21 minus 14, that is 7 upon 2, right? Now we have to find out the sum of this series. So let me write the sum of the series formula, right? So what is our sum of the series formula? We know that sum of the n terms is equals to n upon 2, right? And a plus l, that is first term plus last term, right? We have another formula also, right? Let me write here again just for your remembrance, that is n upon 2, right? N upon 2 times 2a plus n minus 1 times d. This formula is when you have got the n terms, first term and the common difference, and this formula is applied when you have got the last term, first term and the n terms, right? So now we haven't got this n term, right? We haven't got this n, and we have got the l, so we'll be applying this formula right now. Will not be using this formula, right? But still, you know friends, we haven't got this n. We need to first find out the value of n. So to find out the value of n, let me do here. We know here the last term, right? The nth term is 84 here, and I'm just applying here the nth term formula, that is a plus n minus 1 times d equals to 84, right? So our first term is here 7, and we don't know that we need to find out exactly, and the common difference is 7 upon 2, 84, right? Or in both cases 7 is getting common, so 1 plus n minus 1 divided by 2 equals to 84, right? So 7 12 is 84, I can cut, and I got here 1 plus n minus 1 upon 2 equals to 12, or n minus 1 upon 2 is equals to 12 minus 1, or I can write here n upon 2 equals to 11, or n equals to n minus 1 equals to 2 11s are 22, and then n is equals to 23. So what we get now, that there are in this series, right, there are 23 numbers of terms, right? So now just by applying all the information in this formula, we can easily calculate the sum of this series, right? So n we have recently found out that is 23 upon 2. Again, a, the first term is 7 and the last term is 84, right? So just by solving this expression, I can easily find out the value of the sum of n terms. So 23 upon 2, I'm just writing here 23 upon 2 times the 7 plus 84, 7 plus 4, right? It will be 1 11, and carry over again 1 7, right? So 8 plus 1, 7 plus 4 11, carry over 1, so 8 plus 1, that is 91, right? So it will be let me multiply 91 by 23 here, right? In rough 23. Okay, so 3 1s are 3, 9 3s are 27, and 2 1s are 2, 9 2s are 18, right? So 3 7 and 2, that is again 9, right? And 8 plus 2, that's 10, right? 10, and divided by carry over 1, and so 1 and 1, it will be 2, right? So it is 2093 divided by 2, right? So I can leave this answer also right here, but if I want to write in mixed form, then I can write it in mixed form also. So let me divide this by 2, right? 2 1s are 2, right? then there is 0, so I can also write here 0, and now is coming, now this 9 is coming, right? So 2 4s are 8, again 1 is coming, this 3 will fall down here, right? So 2 again, 6 are 12, right? And we get 1, and then what I can write now, that first quotient, remainder upon the divisor, right? This is the mixed fraction of this, or I can say we can also say this is the sum of the n terms, or the sum of the 23 terms of this series, right? This is the sum of this series. We got that, right? This is equals to, sum of this series is equals to 1046 and half, 1046 and half. This is the sum of this series. So like this we have to solve the problems, this kinds of problem. In next video we'll be doing a little bit different problem, right? Where let me just tell you something here. You know, here as we have written both of the formula here, see how many variables here are. Here are 1 variable, 2 variable, 3 variable and 4 variable, right? So in the problem now, you'll be getting the 3, since there are 4 variables, right? You'll be getting 3 variables and you have to find out 1, right? In most of the cases I'm talking about, in 4 variable, out of 4 variable you'll be getting 3 variables, any you can get. You may be getting this, or this, you have to find out this, or you may be getting the last term, first term and n terms, and you have to find out the sum of n terms. Sometime what happens, you may be getting the sum of n terms, you may be getting the suppose first term and the last term, and you have to find out the total number of terms, or it may be something, right? It may be anything, so depending on the situations. And sometime it may be like this, you may be getting common difference, right? And first term and the n terms, and you have to find out the sum of n terms. Sometime what happen, you'll be getting sum of n terms, right? First term, last term, and you have to find out the sometime common difference also. So depending on these all variables, right? See, 1 variable, 2 variable, 3 variable, 4 variable, right? 1, 2 variable, 3 variable, and this 4 variable, and the first term also, right? This is the 5 variable total there are 5 variables. You'll be getting 3 variables and you have to find out any 2, right? In this problem, you know, in this sum of the n terms problem, always you will be given 3 things and you have to find out the rest of the 2 things, right? So I'm talking about the most of the, not in every problem, right? So in next video we'll be doing a little bit different. Okay, we'll be meeting in next video. Bye bye.